So you can see in this problem, in the question, it is shown that is a 4-bar link mechanism, okay, and the length for all A, B, C, D, and up to point E and point F, point G, all our dimensions are given, and the initial input that the link AB has an angular velocity of 10 radians per second, and retardation, that is acceleration, nothing but acceleration, that is 26 radians per second square. Okay, so by the unit you should understand what is given. Okay, so radians per second square means it is nothing but alpha. Okay, so alpha is given and then omega is given in counterclockwise direction, they have mentioned here. Okay, then the angular accelerations of link BC and CD have to be calculated. Okay, so for this, the linear acceleration of point E, F and G, they are told to calculate here. So first you should draw the velocity diagram. So same in the last part of the velocity we had discussed how to solve the velocity diagram. So start from the initial point A. Okay, then from this perpendicular to AB you take a velocity. So it is given in the counterclockwise direction. Okay, so it will be perpendicular to this in this direction. So you start with this A to B. Okay, A to B, and the value for this can be calculated by taking the omega into length of AB. So 10.5 into 0.05, that is in meters. If you take, you get 0.525. Okay, so you can draw a line perpendicular to AB. Then from B to C, perpendicular to BC, so draw a straight line here perpendicular to BC. Then from D to C, whatever is there perpendicular to this line, you can just draw in a perpendicular line from CD, and it will intersect at one point, and that point will be point C. So you can show the arrow mark like this: A to B, then B to C, and then D to C. Okay, so this is the velocity diagram. Next we have to see about the acceleration diagram.
Sir, omega is not given, no, say it is clockwise or counterclockwise.
No,
Omega.
they are given counterclockwise only. Okay, they are actually, you can see the link AB has an angular velocity and retardation of 26 radians per second together. Together they have given for AB, omega and alpha in the counterclockwise direction. Okay, so for both consideration you have to use counterclockwise direction only, unless in any specified for next step, till the initial condition is this in the given problem. Okay, so you have to use the same direction for both. You can see here it is given and counterclockwise together. Okay, so you have to take counterclockwise only. Next, coming to the expression of C relative to A. So this we have discussed yesterday also. Again I will discuss. So if you want to get the acceleration of C with respect to A, so you have to go from C to B, then back to B to A, same as what you have done in velocity. Okay, so it will be acceleration of C relative to B plus acceleration of B relative to A. So that is nothing but FCA is equal to FCB plus FBA, and A and D are nothing but same points. So we consider A and D are fixed points. So let us take A instead and D instead of A. So it becomes FCD is equal to FBA plus FCB, and it can be written as D1 C1. We have taken one number for acceleration. So we have used ABCD small letters for velocity, showing the velocity points. Here for acceleration we take it as 1, A1, B1, C1, D1, like that. Okay, so D1 C1 is equal to A1 B1 plus B1 C1. Now each component has to be converted into two parts, that is two components. So each vector has a centripetal and a tangential component. So in the last class we discussed about that. So one will be FC and one will be FT, centripetal and tangential. Okay, so the same thing FCD plus FBA plus FCB. Now each term you express by two components. Okay, that is FC CD, okay, and FCD for tangential, FCD T, and then FBA C, and again FBA for tangential T, then FCB this component, FCB C plus FCB T. This is for tangential. Okay, so each will have one centripetal and one tangential. So it can be written as D1 CD plus CD C1. So that is from D1 to C1. If you want to get D1 to C1, you have to move from one more point. So let us take it as CD. Okay, so D1 CD plus CD C1. You can give any notation instead of CD. If you are getting confused with some another denotation, you can take something else also, no problem. Okay, so D1 CD plus CD C1. Next, A1 to B1. Okay, A1 to B1. So it will be A1 to BA plus BA to B1. I think there is some printing mistake here. Okay, so it is A1 to BA plus BA to B1. Okay, then B1 C1, B1 to CB, then CB to C1. Okay, so it will be like this, each for getting two components now. Okay, so next you have to draw the table. So watch this table correctly. Yes.
Please explain the equation again, sir. Those equations.
Okay.
That vector equations.
This one. Which one? Which equation? First one.
No one, sir. Centripetal and tangential.
See, we are use the same equations what you use for velocity only. So if you want to get C, if you want to get point relative velocity of C with respect to A, it should move from C to B, then B to A. Okay, so same thing we are taken instead of last for velocity we are taken VCA is equal to VCB plus VBA. So now you are taking F component, acceleration component. So acceleration of C also with respect to A, it will be C to B, then B to A. So same thing we have taken FCA equal to FCB plus FBA. Okay, so this is C with respect to A, and that is C to B, then B to A. Then we replace A by D, because A and D are same points. You can see A and D are same points, and it starts from same point and ends at the same point. Okay, so that we replace by D, so that we get FCD equal to FBA. So the same term I have kept here. So just from the second term I put it as first term. Okay, the rest all things are same. So FCD plus FBA plus FCB. Okay, then this CD can be written as D1 C1, and that is equal to A1 B1 plus B1 C1. Okay, then just I have splitted this term into two parts now. So all the things are same, only I have taken extra two terms there for each, that is one centripetal component, one tangential component. Okay, clear? And
Yes,
this is A1 BA. A1 BA plus BA B1. Okay, you can note on this this thing. This is important, because next you have to calculate these things now. These six you have to solve in the table. Okay, so note down this. Okay, D1 CD. This is okay. This is anyway same thing. So these two you note it down in your paper, so that you remember when you solve the table. Okay, so note down this FCCD plus FTCD for this is equal to FBAC plus FBAT plus FCBC plus FCBT. Okay, so 6 terms are there. So in the table also you should get 6 terms. Okay, then this can be written as D1CD plus CDC1. That is, to get D to C1, I use one more component, that is D1 to CD and then CD to C1. Okay, similarly to get A1 to B1, I have taken A1 BA plus BA B1. Okay, then this B1 C1 is nothing but to get B1 to C1, I have to take one more component, B1 to CB, then CB to C1. So one centripetal component, one tangential component. So centripetal will always parallel and tangential always will be perpendicular. Okay, so now one by one we will solve these terms and calculate. So remember which is centripetal and which is tangential, and then we'll start from RHS side. Always better to start from the RHS because we know VBA. Oh yes, VBA, and then FBA can be also calculated from according to that, because initial condition what is given, from that you should solve, because we know from link AB they are given the velocity and acceleration, both components, the value is known to you. Okay, so if you take the component BA, almost you will be getting the answer for this, and the others are unknown. Okay, so always you can take which is known to you. So let's we'll draw the table. So take this table along with me. Don't just copy the table. First see what I am doing, and then you can note down. Okay, just directly don't note down whatever things are there. First listen what I am telling. Okay, so first term is FCBA. Okay, that is the centripetal part. So acceleration, centripetal acceleration for BA component, that is nothing but A1BA. Okay, so A1BA, it will be AB square divided by AB, where small AB represents the velocity of AB. Okay, so that you remember. AB, small AB means it is nothing but this one, A to B, small letter. AB means velocity value 0.525, what you are getting here. Okay, so small AB is 0.525, so 0.525 square divided by length of AB, that is the length of the link AB. So it is 0.05 meters. Okay, and if you solve 0.525 divided by 0.05, you get 5.51. You get 5.51. Okay, so write down 5.51, and then direction you can write parallel to AB. Okay, so centripetal always will be parallel. Okay, so AB means directly parallel to AB you can draw. That I will tell how to take later. Okay, so first write down parallel. So centripetal always parallel and tangential always perpendicular. These two things you remember. Okay, and since start from point A only, so okay, write capital A. Okay, then we'll come to the tangential component, FTBA or BAB1. Okay, that will be equal to, this is the tangential part. So tangential will be with respect to angular acceleration, that is alpha. So that is equal to alpha into AB. So this we have derived yesterday only. So for the tangential part it will be angular acceleration into length of the link. So alpha is already given in the question. Alpha is already given in the question. So it is 26 radians per second square multiplied by the length of AB. So you 26 into 0.05, you get 0.13, sorry 1.3. Yes, Raghu. Raghu.
Hello,
Raghu.
sir.
Not Raghunandan.
Sir.
I am not asking you, Raghunandan. One more Raghu is there. Akshay.
Yes, sir.
Raghu is from your class, not Raghunandan. I am asking Raghu, only Raghu.
No, sir.
Okay, I think I removed him. Okay. Next, we have to take this value, tangential acceleration part, perpendicular to AB. By the word tangential, you can understand it is perpendicular. Okay. So for this, you have to take perpendicular direction. Okay, perpendicular to AB, perpendicular to capital AB. So that is nothing but parallel to velocity value only, because already for velocity you take perpendicular to the length of the link. Okay, so that is nothing but already you have drawn that velocity, so that is parallel to small ab, or it is nothing but perpendicular to capital AB, anything or any one you can use. And this direction you can consider from small a, because already you have drawn this velocity, so you can use the small a. If you are taking capital A part, that you have to take perpendicular value. Okay. Next, FTCB. Now tangential component for CB, that is nothing but B1 to CB, that is from B1 to CB, that will be equal to BC square, small bc square, that is the velocity of value BC, divided by the length of the link BC. Okay, so BC, how much you got? B to C you got 0.34. By measurement from the velocity diagram, you got 0.34. So without calculating of velocity diagram, you can't go acceleration. That's why for solving acceleration diagram, you need to draw the table first, and to get the table, you should get the values of velocity. So always velocity diagram you have to draw, and then you have to take this table. Then you can draw the velocity acceleration diagram. Okay, so small bc square, that is 0.34 square divided by the length of BC. So BC is how much? So BC is given as 66 mm. So I convert in meters. So I get 0.066. So I get the value of 1.75. And it should be parallel to BC. Parallel to BC. Starting from again B, capital B. So this is the centripetal part. Okay, this is actually centripetal. There is some mistake. You can correct this. Okay, this is FCCB. This is a centripetal part. Make this correction. Okay, don't take this at tangential. This is a FTCB. We will take next one. So this is a FCCB. This is centripetal part. So centripetal part you have to take parallel. Okay, so calculate this and see, we get 1.75. Next we take FTCB. Next we take FTCB, that is CBC1. Okay, and that we don't know, because alpha for this CB length is not given. Okay, so we'll keep it as dash. So not given, that's why we will not take this, we'll just keep it as blank. Okay, but we know the direction. Okay, we know the direction, we don't know the magnitude, but we know the direction, because when you take CB, it means it should be perpendicular to that link only. Okay, so perpendicular to BC you can take it. You can know, you know the direction perpendicular to BC, or nothing but B1 CB. Okay, So this not known to you from where it will start, so just leave it blank. Then FCD centripetal, so it is D1 CD, so DC square by DC. DC square by DC means DC already you have calculated, so it is 0.39 meter per second. So you take 0.39 square divided by the length of DC is 0.56 meters. So solving this you get 2.72. Solving this you get 2.72, and this direction you have to take parallel to DC. This direction you have to take parallel to DC, and the sense should start from D, because D point already you know, from there you can start. C is unknown, so to start from D only. Then last one, FCD tangential, that is CD to C1, that is also unknown. Alpha is not given here. Alpha is not given, so we don't take this, just give it a blank. But you know the direction, it is CD means perpendicular to the link of this DC or D1 CD. So this leave it as blank. Okay. So any doubt till here? Any doubt till here?
Sir, what is that sense means? What is that?
Sense means the starting point. So from there you can start. So if you want to get parallel to AB, you can use the position of A, point A, from here, A to B like this, the sense will start. If next you have to take from D here like this, so I can start from the sense of D, D to C. I can't use C because I don't know. B, from A to B I know, B to C and D to C to D I don't know. So I can take a line from B to C like this, and D to C direction I can get. Okay, I don't know the magnitude. So where it will coincide like velocity only. So I have taken from A to B, but I don't know the value of B to C, and also I don't know the value of D to C here. So what I do, I just take the direction perpendicular, and where it will meet at that intersection will be C. So same thing I have to do for acceleration also now. I don't know this. In between I don't know. Only up to A I know and up to B I know. Then C I don't know, so I'll start with D, because the sense from to get C now I have to start from D, because D already is known to you. Okay, so that sense I have shown here. This is just an optional thing. Okay, no need means you can just write for your understanding, but anyway these values are, and this direction is more important. Magnitude and direction is important, and vector what you are going to label. So in diagram you should be able to understand this. So take down this table. Take down this table. And when I start with the acceleration diagram now, and I think in one class this problem will not be completed. So that's why I have to extend to the next class also. That's why I took today's class also morning, so that we can continue in the next class at 11:30 also, because it will not be over soon. It will take some time. Acceleration diagram first time when you do, you need some time. In regular class also I take around 2 classes for this to solve one problem. Okay, so it will take some time. You do it slowly, but do it correctly. I will go very slow. I will take only one line. That is only one line means one vector. That will complete only AB now. Okay. Next the second and third part, that is for BC and DC, that will do in the next class. Okay. Only you take today only about AB. So to draw that only will take some time. Okay. So don't hurry. Do it slowly and do it correctly. I want you to do correctly. Simply rushing the things and ending up in problems is not the solution for us. Okay. So I will just go very slow. Try to see what I am doing. Okay. Take some time, but do it correctly. Okay. So shall we start? Have you noted down the table? Anyone tell yes or no?
Yes, sir. Written, sir.
Yes, sir.
Yes. Okay. So first we will take only these two things today. Okay. Okay, only these two things in the this class. Okay, after 11:30 we will see the next two. Okay. So first you have to take now FCBA and FTBA, and finally I want the resultant A1 B1. Okay, so A1 BA, then BA B1. So this will take now. So you know the value also for both the things, and you know direction also. So very easy to draw. Okay, so let us take how to draw this. So I will not explain much of this. So I will directly draw a line, but you have to take one pole point, that is A1 or D1, that is the initial point, and from there you have to start the point from A1 and taking the first vector, that is from A1 to BA, and to the first vector add the second vector, and to the second vector add the third. So directly when you get the vector fourth is known in the direction only, therefore through the head CB of the third vector draw a line perpendicular to BC, and the point C1 of the fourth vector is to the line on this line. So starting from this we'll take the another vector. Okay, so go on doing. So we'll start with the initial point. So take one point A1 at the top side of your sheet, because all will come lower to this A1. Initial point to locate at the top of the sheet, you can see A1 will be at the top and rest all things will be at the bottom side. Okay, take a suitable scale and draw in a little bit big sheet, because this is very big and lot of confusing also when there will lot of lines should be coinciding like this. So if you take a very small scale, all will come in the same line later. You can see at small distances you get different lines. Okay, so take one point A1, okay. So now from A1 what you have to do, you have to go to the table. So A1 BA is parallel to AB, means it should be parallel to the link AB, so that is of 60 degree length. Okay, 60 degree angle, 60 degree angle AB, and what is the value of AB? That is A1 BA, that is 5.51. So take a suitable value of 5.51, take a suitable value of 5.51 and draw parallel to AB, draw parallel to AB, draw parallel to AB. So you will be getting, taking a parallel, you will be getting a line like this, that is from A1 to BA. Don't concentrate on the entire figure, just see what I am taking with this red color lines. So you will be getting parallel to A1 BA in this manner. So you will be getting a parallel to link AB and you will get a 60 degree angle in this manner, and you take it as 5.51. You know this value 5.51. So take a suitable scale 5.51. You can take better, you take at least minimum 5.51 centimeter minimum. You can take double scale also, no problem. You can draw scale more than double also, that is also okay. If you have around 11 centimeter area, you can take double scale also, 2:1 also you can take. Okay, so 5.51, at least you can take this 5.51 meter per second square as at least 5.51 centimeter, at least that. Don't take less than this, otherwise you will not get a line at least. Minimum you can take, or if you have entire sheet for you, you can take this 5.51 equivalent to around 11 centimeter also. That is also okay, double it. So draw a line in this direction, you can draw A1 to BA. So as it is counterclockwise direction, we take it in reverse direction, because A to B is in this direction, so we take reverse. Okay, so that's why we taken as reverse, A1 to BA in this direction, downwards. Okay, next BA to B1, BA to B1, BA to B1 is 1.3 value, is 1.3 value, and it is perpendicular to AB, perpendicular to AB. Okay, so draw a line perpendicular to AB or perpendicular to the velocity diagram only, or parallel to velocity diagram. Okay, so perpendicular is this value, perpendicular to this, or it is nothing but the same parallel to this velocity A to B. Okay, so just whatever line you have drawn now from A1 to BA, just perpendicular to that, like this, you will be getting the value of 1.3. You can take that in 1.3 value and then take BA to B1. So this up to here you will get B1. A1 to BA, then BA to B1. So this is 5.51. This is from BA to B1, it is 1.3. Okay, so A1 to BA, then BA to B1. Next, join this resultant A1 to BA, A1 to B1. So this resultant, what I am taking here, resultant, this straight line. So this part is the final vector of A1 to B1. So finally I want this A1 B1. So first start from A1 to BA like this, then from BA take 1.3, and then final A1 to B1, if you join straight line you will get A1 B1. Completed. So only take up to here, you draw this much and keep it ready to solve the next step. Okay, so just to do up to here.